We would like to help you understand the fundamentals of DTRelay. So before we do, we will explain where it started. Our original goal was to allow HTML and JavaScript to communicate securely over the internet. This is how we did it. First, to understand the problem, you have to understand the standard flow of an application using OAuth to authenticate through an API to access Facebook, Google, Twitter, or any other third-party application using OAuth. The standard process includes a request sent to the API, which requests the use of an OAuth token. Next, the OAuth token is sent back to the device and then asks the user to grant permission. During a request, the OAuth token is available in the request, and the only thing that keeps it protected is the SSL. But if you can get past the SSL, then you have access to the token. Once the user grants access, the token can be used to act as a user and it does not need a password. To us, this is a problem. If an API no longer needs a password, then what good is a password? There are known vulnerabilities with security tokens, and many hackers have been able to exploit them. We have the solution. Don't pass a security token. Let me explain. All that token process can still be done behind the scenes inside of DTRelay, but the security token is never sent back to the device requesting it. Instead, we relay a token that is sent with a random identifier that can never be deciphered by a hacker. Therefore, the hacker never gets access to the security tokens because they are never sent back to the client. This is all done behind the scenes where the hacker cannot get access. We put DTRelay in the middle, which does a variety of things. Before, it needed to do this dance back and forth in server components to negotiate the OAuth flow. By consolidating this into DTRelay, just like any other OAuth proxy would do, you now have the server side in DTRelay and it does not need to send back sensitive information to the client. Therefore, the client can now work with pure HTML and JavaScript. Until now, tokens were vulnerable to hackers on the client side, but since we don't send tokens back, nor do we send any sensitive information back, we've eliminated that risk altogether. Before we go too much further, let's talk about scaling to millions of users and how it can be done very easily with DTRelay. When using DTRelay, being able to build apps with just HTML and JavaScript is a huge benefit. We can post our apps on a content delivery network because we're using HTML and JavaScript, not compiled code. This was the original goal, only using JavaScript to communicate securely with an API, but it also has so many other benefits. By using a DTRelay token, we also protect the connection and make it safe with our token. Again, now there is no OAuth token passed back to the client. Another big need is new serverless technology that can help systems to be independent and modular. DTRelay also makes this possible because you can easily now separate modules using delegates in the relay itself while using the API for all your other needs. Therefore, the actual app that the client uses are pure HTML and JavaScript, and that runs much faster and is a much better experience for the user. Now I want to talk about delegates, which are revolutionary. Never before has a developer been able to create modules with such ease while keeping them secure and safe. They can be used as a gateway authorization on behalf of other APIs. Developers can now create their own delegates that act independently of the API. This allows for a place for developers that need to create a secure process can do so, while developers working on the API can do so independently. Example, you can use a delegate to register consumers in a more consistent way. You can create consumer registration models as a delegate, and within that module you can maintain a global list of apps across vendors. That way, you could block apps from accessing it that do not need access to the API. Delegates are also a place to consolidate logic from other apps, blocking inappropriate posts, and doing so much more. To recap, delegates seamlessly manage the OAuth 1 and 2 process for you. They can be used as a gateway authorization. They can manage secure file uploads and downloads independently of the API. They allow for work to be done between the client and the relay and can work independently of the API. And most importantly, they allow for innovation so that new technologies can be created to do so many more other things. DTRelay protects the communication from the client to the API. Delegates can act as a facilitator, allowing all communication to be monitored. They can authorize traffic coming in and out of DTRelay. And delegates can do important things such as send emails, can work with other APIs, and do so much more. Developers can now create their own DTRelay delegates that act independently of the API. Delegates allow a place for developers that need to create secure processes to do so, while still allowing other developers to do work on the API independently of those processes. Another important part of DTRelay is that every parameter in a DT token can be protected by the use of a checksum. Although this is a very important technical process, we don't want to get too much in the weeds on this video, but we can keep it at a high level. Protecting parameters was one of the things in OAuth 1 that made it so difficult to accomplish for developers. And it was also one of the reasons OAuth 1 is no longer used today, even though it was the most secure solution. When passing parameters, such as values, lists, files, or anything else, you want to make sure that they are not tampered with. DT tokens use a checksum process to validate that happens. Now you can verify in DTRelay that what was supposed to be sent is actually sent. This is critical for secure transmissions, and we do it. To finalize, we are going over an overview of the benefits of DTRelay. DTRelay knows that an authorized device is sending the information, which means we can now know who is requesting information. So if a hacker tries to access it and manipulate the request, DTRelay can reject that request. A server can now know who it's communicating with. We protect against tampering so that if a hacker is able to eavesdrop, they won't be able to do anything with the data. Consumer keys stay in the relay and therefore they are protected. DTRelay also protects against session hijacking. Instead of using a session ID, we have a DT token that is a smart ID that is also randomly generated. And DTRelay can tell that we have not seen this ID before. No one can just steal your session ID and use it. During communication, you want to know that you are talking to the person that you think you're talking to. DTRelay knows exactly who you're talking to. Both ends of the communication can be verified, therefore you know exactly who you're talking to. When it comes to forge requests, you can only use HTML and JavaScript to solve this problem on the client side, or with any other open language. One alternative that Yahoo came up with was the ability to create a token on the client that a hacker cannot figure it out. But if a hacker has access to it, a determined hacker can figure anything out. We put the token generation inside of DTRelay on the server side, where they cannot figure it out. The token is generated on the server side. The hacker is never going to be able to determine what it's going to be when it comes back. Plus, the token value is randomly generated on the server, so no one knows what it will be. And there is no information on the client side to determine what it will be. And there's no information on the client side to determine what it will be, or even outside of that. The OAuth tokens are never sent to the client. They are always kept in the key store. We never expose security tokens, consumer credentials, or anything else that's sensitive. DTRelay is highly scalable. Because our applications can now be pure HTML and JavaScript, it contains no other logic. There is no assembly during the request. There are no config parameters that get sent over the wire. We don't need consumer keys. Everyone gets the same copy, which causes us to highly optimize and scale. All the server needs to do is fire the same sequence every time. The app can be 1.5 megabytes, the client can keep it local while the browser is caching it. We can put it on a content delivery network and it will be 3 times faster. We have actually seen a 70% performance increase with this. Instead of the first request taking 4 seconds, it only takes 1 second. A great example of something we all use on a content delivery network is something like a commonly used JavaScript file called jQuery, or even Angular. It gets distributed across the CDN. Instead of having one server taking all the load, they are distributed globally because everyone uses the same library. Now you can do the same thing with your apps because you can use pure HTML and JavaScript. DTRelay is a major improvement to the world of developers. While we continued to innovate, we saw the ability to improve security and improve the user experience. Your developers can easily set it up and implement it in your projects. Now you can try it for yourself and see how your technology can be revolutionized and help make the internet a much safer place and give users a better experience. You have to see this in action, running in your own environment.